we start the next section, which is on triangle trigonometry. So for tonight's homework, you're going to need to know the first four formulas. We're not going to use the law of sines and cosines still next time. So now you're going to get to use your calculator on quite a few problems. So sometimes you're going to have to jump back and forth between degrees and radians. So you can do that on your calculator very easily, right? Right? Just in the upper right hand corner. Just, yeah, it's easy. Oh gosh. Yeah. So before we start doing some problems, do you guys know how to, do you guys even know minutes, degrees, and seconds? Did we learn that last year, the basics? I see one person saying yes and several people saying no. Okay, because sometimes you're not going to be given like 23 degrees. Like, how do you find the cosine of 23 degrees? Well, that's easy to punch in on your calculator. But what if it's like 20, no, let's do 12 degrees. 12 degrees. What if it's 12 degrees, 34 minutes, and 56 seconds? Do you know how to punch that in on your calculator? Some of you are going, what is that? Well, you guys know what a degree is, right? If you have a circle, and you break it into 360 parts, then one of those is called a degree, right? But what if you have a degree and you break that up into 60 equal parts?
Minute.
Then one of those is called a minute. So if you have a degree and you break it up into 60 equal parts, one of those is called a minute. And then if you take a minute and you divide that into 60 equal parts, each one is called a second. You guys never heard of these before? What? How can you take trigonometry without knowing that? So the first thing you got to be able to do is, can you punch this in on your calculator? Okay, so first of all, you guys better practice, because you guys got to be really good at your calculator now. So first, put your calculator in degree mode. Okay, one way to punch it in is just like this. But if you don't know how to do that, like if you forget on the test, then you can do this. This is the way we did it in the old days. We had to go cosine 12 degrees, well, assuming your calculator's in degree mode, plus 34 over 60, right? Because there's 60 degrees in 60 minutes in a degree, plus 56 over 3600. Because there's 60 seconds in a minute, but then there's 60 minutes in a degree. So there's 3,600 seconds in a degree. So here, this is how you can check to see if you got the correct thing. So let me take out my calculator, which is over here. And you guys know how to tell if you're in degree or radian mode, right? I hope. Like I'm in degree mode because got the degree sign in the upper right hand corner. So I'm going to punch in cosine of 12. I'll do it the old fashioned way first. Plus 34 divided by 60. Right arrow. Plus 56 divided by 3,600. Right arrow, right arrow. Press enter. Patooey! Okay, now, before we even do the next one, cosine 12. Now, do you guys see a degrees, minutes, and seconds? Yeah, right here. You see the natural log button right above that? You see in the blue, got degrees, minutes, and seconds. So once you punch in the degrees, you go shift, press that button. See how the degree sign comes out? And then you punch in 34. Shift, press that button again, and then whoo, the minutes come out. And then you go 56, shift, press that button again, and then the seconds come out. Right arrow, and then enter. Woo! Hey, look, it's the same number. Well, it should be the same number. So I don't care really which way you punch it in. You got to be able to punch it in somehow. And like I said, if you don't know how to operate, because every calculator has its own system, yeah? So if you can't figure out how to do the degrees, minutes, and seconds, there, just do it the old-fashioned way. Right there, it works every time. Now sometimes I'll give, well, I don't know, depending, right? Sometimes I'll give you the information like that. Sometimes I'll just give you, like, I'll make it easy for you. 12.736 degrees. I'll give it to you in decimals. You can just punch it in like that, yeah. But you got to be prepared because you don't know how the information is going to be given. Now, before we even do, oh, now I'm covering up the notes. Boo. Now let's just move it on the side there. All right. So let's go over these formulas. You recognize the first one, Heron's formula? We did that in Lin Quad, right? We were supposed to learn that in geometry. So, anytime you know the three sides of a triangle, because what we're going to be doing in this chapter is you're going to break things, you know, trigonometry is the study of triangles, right? That's why we call it trigonometry. So we're going to compute sides and angles and areas of triangles. That's what we're doing. So if you know the three sides of a triangle, the best way to find the area is to use Heron's formula, right? So what is that? Area. Usually we represent area with the Greek letter kappa. Square root of s times s minus a times s minus b times s minus c. And what is s? The semi-perimeter. That's why we use s. So semi-perimeter means half the perimeter. A plus b plus c over 2. Anyway, you did this in Lin Quad. So what you need to learn how to do, you got to relearn, is you guys remember how to store numbers on your calculator? Because remember, you cannot use a rounded value in another computation because you get rounding errors. Because if you are off in the third decimal place, points are coming off now. So you got to use all the decimal places if you're going to make another computation. That's why you want to store things. So you guys remember how to store things? Okay, let's review. Anyway, look back at your Lin Quad notes if you forgot. So let's say you computed this number right here, like here. This number right here, 0.97598. But you cannot just use 3 decimal places if you're going to use it in another computation. You got to use all. So once you have this number, you store it. Okay, where's the store button on this calculator? Yeah. It either says STO usually, or there's a right arrow. Anybody see it? Oh, it's on the top there, right here. Store it, and you can pick any letter from A through Z. What letter you want to pick? Okay, where's B then? Oh, right here. B is right there, so you got to go alpha B. If you press enter, that number is now stored into B. So if you have to use this number in another computation, you simply put B there. Question? No. So like for example, if you have to use it in another computation, you just go alpha B, and then like say you have to square it, and then you got to add 2 to it. Press enter, boom. So your calculator plugs it in with all the decimal places, it squares it, and it adds 2. But you're going to find out, you guys know this from last year, didn't you guys store values last year when you did the law of sines and cosines? Or did you write down all the decimal places on your paper and punch it in like that? Come on, you guys got to remember something. Oh boy. Well, I'm telling you, it's just easier to store it rather than write it down on your paper and then punch it in again. That's craziness. Oh, I guess with this calculator, can't you just copy and paste? I never learned how to do that though, so. Just store it. Well, I guess you can copy and paste if you want, but make sure you copy the right number. That's the thing. Okay, so the next formula. Okay, before we go over that formula, there's a skill you need to have, and you guys who are taking physics now, you should already have it. Because when you componentize the vectors in the free body diagram, you guys did that, right? And those of you who are 10th graders are going to do it next year. If you have a right triangle, and you know the hypotenuse, and you know an angle, how do you find the length of this adjacent side? H, come on, you guys in physics, you guys should be experts at this. H cosine theta. How do you find the opposite side? H sine theta. Isn't that how you componentize every vector that you did? Yeah, this is a very important skill, and it's going to be important now, too. And don't forget this until you finish your math career. Okay, so, do you remember this formula? If you have a triangle, and you know two sides and the included angle. Can I assume that you guys know the basics? Like when you have a triangle ABC, then angle A is opposite side A, angle B is opposite B, and angle C is opposite C. So if you know two sides and the included angle, that means the angle between them, then what's the fastest way to find the area of the triangle? 1/2 AB sine C. Surely you got to remember that from last year, right? Well, whatever, you're going to have to know it now. Now, where did this come from? Well, to find the area of a triangle, normally you go 1/2 base times height, correct? So if we take this to be the base, okay, let's say this is the base, how do I figure out the height? Isn't the height just this right here then? Okay, but look what we have. We have a right triangle. Look, you know the hypotenuse, and you know this angle right here. So how do you find the opposite side? What did we just learn? A sine C, right? So that's the height, A sine C, and voila, 1/2 AB sine C. So anytime you have a triangle, you know two sides and the included angle, this is the fastest way to find the area. 1/2 AB sine C. These formulas need to be memorized. They have to be at your fingertips. Or we're going to have to be weak like last year. I think I gave them the formulas at the top of the page. Yeah, but you guys are not having a test. You only have a quiz, so I don't think we need to give the formula, yeah? Okay, what about the next one? If you have a circle, here's the center of the circle. If you know the radius and the central angle in radians, then how do you find the arc length? Well, there's a formula right there. It says r theta. How do you get that, Mr. Park? Last year we just memorized it for the quiz and we purged it. Well, isn't the arc length right here simply a fraction of the entire circle? Just like when you took geometry, you guys measured the angle in degrees, right? Like they said, okay, the radius is 5 and this angle is 30 degrees. Can you find the length of that? That's the kind of problems you get on the SAT, right? So how do you do that? Well, what is the circumference of the entire circle? Really? 2 pi r. So isn't this just a fraction of the entire circle? What fraction is it? Well, theta over 360, if you're doing it in degrees, right? So you multiply by theta over, doesn't matter where you multiply it. Theta over 360. That's the way you did it in geometry because you didn't know anything about radians, but now you do. So what fraction of the circle is it if you do it in radians? What is 360 degrees in radians? 2 pi, and what do you know? The 2's cancel out, the pi's cancel out, all you're left with is r theta. So the arc length is equal to r times theta, but theta has to be measured in radians now. Does that formula look familiar from last year? Really, but not this one? That's just strangeness. Now what about the area of this sector? I hope you guys know that's called a sector, yeah? Well, isn't it a fraction of the entire area? Well, what's the area of the entire circle? Pi r squared. So what fraction of the circle is it? Well, if you're working with degrees like you did in geometry, didn't you go theta over 360? Yeah, but we're not doing it in degrees, we're doing it in radians. So we change the 360 to 2 pi. What do you got? The pi's cancel out and you get 1/2 r squared theta. That's the area of a sector. I'm not going to even ask if you guys recognize. You guys need to know all of these formulas. They need to be at the tip of your fingers. Okay, so now we can actually solve problems. What kind of problems can we expect to see this year? Okay, we'll start off with the easy kind, the kind you get on the ACT. All right, suppose, here, the flagpole over there. Let's say you want to find the height of a flagpole or a tree or whatever, or a building. You want to find that, so what do? And assuming it's perpendicular, yeah? So assuming, so you have an instrument that measures angles. So what you do is you walk some distance away from the pole or the building, whatever it is. How far away you want to walk? 100 feet? Okay, and then you have these things that can measure angles. So let's say you measure this angle here, woo, and it comes out to, give me something, 32 degrees, 17 minutes, and we can't have 60 something, 46 seconds. What is the height of the flagpole? Now, whenever you have a right triangle, you just use SOHCAHTOA. Right? You guys learned that from geometry already, right? SOHCAHTOA. Tomorrow, though, well, I'm not going to see you tomorrow, but Friday, no, I'm not going to see you Friday either. Monday, what happens if the triangle is not a right triangle? That's when you use the law of sines and cosines. But it is a right triangle, so we use SOHCAHTOA. How do I know which one to use this department? Well, here's the angle. What is this? Adjacent. What is this? Opposite. Which one has opposite and adjacent in it? Tangent. So the tangent of 32 degrees, 17 minutes, and 46 seconds is equal to opposite over adjacent. Can I solve for x?
Yes.
Yeah. So therefore x, which is the height of the flagpole or the building or whatever it is, it's 100 times the tangent of 32 degrees, 17 minutes, and 46 seconds. Punch that in your calculator. Here, you guys should practice. Now, of course, I'm not going to ever give you a problem that simple. But that's what the kind of problem you get on the ACT. So what is it? 100. Make sure you're in degree mode, yeah? For this problem. So, again, you have to switch back and forth depending on the problem. 32 degrees, 17 minutes, and 46 shift seconds. Enter. Oh! So the flagpole is 63.208 feet. Did you guys get that? Now you round off. So when you write your final answer, then you round off. But otherwise, if you're going to use it, so if you need this length in another computation, then you should store it. Store it in any letter from A through Z. 63.208. So 63.208 feet, that would be your final answer. This is fun. You get to use your calculator. Now, like I said, this is just way too easy. This is like the kind you did in geometry. But now we're in pre-calculus and we're in honors, so we're going to have harder, tougher problems. Okay, let's think of a regular polygon. How many sides do you want this polygon to have? Something bizarre. 23. Okay, let's do it then. So we have a regular 23 gon, a Michael Jordan a gon. Or you guys, what do you guys do? LeBron James a gon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Not bad. And each side has a length of what?
X.
No, give me a number.
1.
Okay, let's go with 2 then. Okay, so find the area of this regular 23-agon. I'm sure there's a word for it. We'll just call it a 23-agon. And it's regular. You guys know what regular means, right?
Yeah.
That means all the sides and angles are equal. Okay, so how do you find the area of this thing? What do you do? Okay, one thing you can do is you can remember some geometry. Now, Mr. Matsunaga said he drilled this one. We were just talking last week about this at the department meeting. What is the area of a regular polygon? There's a formula that we learned in geometry.
N minus 2, right?
Huh?
Is it n minus 2 in there something? Right?
No, that's to find the degrees.
Oh.
Okay, that's this. 1/2 AP. Does that look familiar? Oh my goodness. Don't make me yell out the window. What does A stand for? We'll come back. No, this is the area. Okay, what is P then? Perimeter. A stands for? There you go, apothem. Yes or no? You heard that word in geometry. So therefore, you know why they taught it to you? Because of this formula. Do you even remember what an apothem is?
The center to the outside, right?
It's the distance from the center to the midpoint of the side. Like that. That's what an apothem is. Okay, but let's just pretend we don't know anything. Mr. Park, I'm not pretending. So is there a way you can figure out the area of this thing? Yeah. Why not like draw this and this? Isn't that a nice isosceles triangle? Okay, so I can just go 1/2 base times height, or I can go 1/2 AB sine C. I mean, there's so many things you can use here. You don't have to use this formula. Okay, so if I can find the area of this one triangle here, can't they just multiply it by 23 and get the answer? Because there's 23 of these. Okay, so let's see if we can do it. Can I find the area of one of these triangles? Well, let's just use the old-fashioned formula. 1/2 base times height, and then you multiply it by 23. Okay, what's the base?
2.
2. Oh, that's easy. How do I find this height right there? Let's call that H for height then. Well, if I knew either this, because this is 2, which means 1 and 1, right? If I can find either this angle or that angle, I can use SOHCAHTOA, because it's a right triangle. Can I find that angle?
Yeah.
Well, what's this angle here? Right there.
360 divided by 23.
360 divided by 23, right? So that angle there is 360 divided by 23 degrees now. We're in degrees. So therefore, what is half of that then?
180.
180 over 23. So this angle here is 180 over 23. Everybody following? So, I got, what is this? This is the, what are we trying to find? This is the adjacent side, and this is opposite. So which one has adjacent and opposite? Tangent again. Ah, it's the same thing. So let's write this down. Tangent of 180 over 23 degrees is equal to opposite over adjacent. Can I figure out what the height is now? Yeah. So H is equal to 1 over tangent 180 over 23 degrees. Or can you change that to cotangent of 180 over 23 degrees? I would prefer not to, Mr. Park. Yeah, but see, now it's easy, because don't you have the cotangent button on your calculator? See, all the old calculators, they only have sine, cosine, and tangent, and then you gotta do other things to find the other ones. Okay, whatever. So you're more comfortable with that one. So 1 over tangent, 180 over 23 degrees. But our calculator is in degree mode already. So all you have to do is punch that in on your calculator, and that's the area of this regular 23 I got. But look, the 1/2s cancel out. Do you have the ganas to do that? You guys know what ganas is? That's an important word in calculus. Do you have the ganas? Who takes Spanish here? Okay, what is ganas?
Isn't it balls?
Huh?
No? I don't know.
No, not do you have the whatever the word you said there. Desire.
Oh.
It is desire. Okay, anyway, so once you do this, can I trust you can punch this in on your calculator? All right, let's look at another problem. And I know Mr. Masanaga told you guys this. Don't worry, he tells us everything. Okay, here's a circle. What is the radius of the circle? Give me a number. You guys can't even come up with a number.
2.
2. How about something like E? How about something magical?
69.
Okay, and let's say the central angle is, and then let's do it in radians. Okay, let's do radians. Give me a radian measure for the angle.
32.
Okay, wait in time out. Come on. That's too big, because 1 radian is 57.3 degrees, right? So what do you say, 32? That's just too much. This angle cannot be bigger than 180, so 2 point what?
5.
2.5, okay, that's, well, actually then it would look like this. Okay, 2.5 radians. Okay, so what if I connect, what is this thing here called? What happens when you have a segment that connects 2 points on a circle? What is that called? It's chord. It's called a chord, okay? Now what is the region bounded by the chord and the circle, like right here? What is this region called? Mr. Matsunaga said he guaranteed that you guys would know it. It's called a segment of a circle. Does that sound familiar? It's on the worksheets that you guys did. Okay, I'm telling you right now, this problem is definitely on the quiz, whenever we take the quiz on this. It's called see, if you have a line, then you have a segment of the line. You guys know what that is, right? But if you have a circle, this thing here is called the segment of a circle. Find the area of that segment right there. Mr. Park, I don't have a formula for that. Well, you gotta think. How can I find the area of this segment right here? Well, what do you know how to do? Isn't this, what is this called? A pie piece. Or a pizza slice. Anybody take a pizza slice that big? What is that called again? Rhymes with nectar. It's a sector. Do we know how to find the area of a sector? Yeah, we got a formula for it. 1/2 r squared theta. Okay, what's the area of the sector? 1/2 radius squared times theta, measured in radians. That's the area of the sector. But I don't want the whole sector, I want the segment. So what do? You subtract the triangle. Now what do we know in the triangle? I know 2 sides and the included angle. And what formula should I use? Is it still written here? Oh, it's erased. If you know 2 sides and the included angle, what's the fastest way to find the area? 1/2 AB sine C. That's the fastest way. So, I'm going to subtract the area of this triangle, which is 1/2 AB times the sine of that angle, which is 2.5 radians. So that means you need to put your calculator into radian mode now. So you're going to have to switch back and forth. That's because the angles are given in radians. Okay, can I trust you can punch that in? Just make sure you're in radian mode now, because if you're in degree mode and you're supposed to do it in radians, you're going to be in big trouble. Just like when you take the AP Calculus exam next year, If your calculator is not in radian mode, there's no way you can get a 5. You will not get a 5 on the AP exam. And if you go to BC Calculus, almost everybody gets 5s. Maybe there's one person that might not get a 5. Everybody else gets 5s. That's just the way it is. Okay, now let's do a variation on this problem and we're done. Okay, so here. Okay, I'll make up this problem. In fact, I think this problem is on the final exam. Not I think, I know. Okay, find this angle. Okay, well, give me the radius of a circle. Give me any kind of number.
70.
What is this fixation with 30 something? Okay, 7 is good. Never mind. Okay, find out what does this angle have to be so that the area of this segment is, did you say 2?
Yeah.
Okay, I like that. Okay, give me the angle here so in other words, you guys know how this works, right? What does the angle have to be so that this area will be exactly 2 square units? Okay, both of these problems are on tonight's homework, okay? And I'm pretty sure this one's going to be on the quiz too. Plus it's on the semester exam. How do I start this? How do I find the area of a segment again? The sector, we just did it 1 minute ago. Sector minus triangle, right? Okay, what's the area of the sector? 1/2 r squared theta. But see, now we don't know what theta is. Like that problem, we knew what it was, but we don't know what it is. Minus the area of the triangle. And what's the fastest way? If you know 2 sides and the included angle? 1/2 AB sine C, correct?
Yes.
And I want that equal to
2.
2. There you go. Did we learn how to solve equations on our calculator? How can you solve any equation on your calculator, or inequality for that matter? Make one side 0. So on your calculator, you will graph 1/2. Do you have the ganas to change that to 49?
Yeah.
Ganas means desire now. Minus 1/2 49 sine x minus 2. Graph that on your calculator, and what are we looking for?
Wait.
Whenever it crosses the x-axis, that's going to be your answer. Now, does my calculator have to be degree mode, radian mode, or does it matter?
Doesn't matter.
No! Anytime you graph anything with trigonometry in it, it has to be in radian mode. Okay, I think we better practice. Look, I'm doing it. You guys some of you are just sitting there like staring. If I can do this in my sleep, you guys gotta do this when you're awake. Okay, so what do? Do I punch it in here?
No.
No, you're graphing. So you gotta go to, I don't even know, what is the app function? Oh, it's there already. Okay, let's get rid of that one. Shift clear. Okay, wait, I gotta change to radian mode. Boop. Okay. Oh, that's so easy. So, you wanna type in 1/2 49, or do you have the ganas to go 24.5? You have the ganas. X minus 24.5. Just make sure if you do this, though, you do it correctly. Sine x minus 2. Enter. Did I type it in correctly? Okay, now, should I just press the plot button? Well, I have no doubt that a lot of you will. I told you guys, set the window. Because okay, plot set up. Okay, what does x represent in this problem?
Theta.
Theta, which is the angle. So you can't have a negative angle, so 0. And what's the now look at that picture. What's the maximum theta can be?
2 pi.
No. Because if you went past 180 degrees, it's just going to be on the other side, right? So the biggest theta can be is 180 degrees or pi. So let's go pi. Where's the pi button? Right there, shift pi. Enter. Okay, what about y? What does y represent? What? Oh, I'm sorry. Okay, never mind. You know what? We're not trying to find the maximum or the minimum. We just want to see where it crosses the x-axis. Okay, so then it doesn't matter. You can put in any negative number you want for y. How about -2? And then 2 for y. Because all we need to see is the graph crossing the x-axis. Okay, now let's press plot. Boom! Whoa! See, the graph crosses the x-axis right there. This is your answer. So how do you find that? Menu, function, root. Boom! 0.797 is your answer. So, your answer would be, when this angle is 0.797 radians, that's when that area will be exactly 2 square units. But then, what if I say, convert your answer to degrees? You have to do this on the SAT, I believe. Like if this is radians, let's practice. How do you convert radians to degrees? Dimensional analysis. We want to cancel out the radians, put degrees on the top. What do we know? 180 degrees is equal to pi radians. The radians cancel out. Then you punch that in, boom, you get your degree answer. But you know what? I'm not going to do that to you. So it's kind of like a hint. If I ask you to give the answer in radians, that's a hint your calculator should be in radian mode. Okay? If I give you the problem with all kinds of degrees and things, then that's a hint. You should be in degree mode. So I'm not going to ask you to convert, okay? We'll save that for calculus. So these are the kinds of problems you're going to see. And there's some other ones. I don't want to, you got to think, this is problem solving. If you want to get good at problem solving, you got to sit down and do problems. Don't just watch my video or look at the solutions and just copy it. You just got good at copying, right? All right, any questions then? Then we are done. We finish early. Wait, I'm not going to see you till... Oh, you guys want to play a game then? I made a game last night. No, actually I made it this morning. Oh. Well, I figured this game, you can really only play this at ELI. I don't know if this game would fly at any other school. Maybe Punahou. Wait, let me stop this thing.